All right, guys, today we're going to work on this new thing called logarithms, or it's abbreviated as log. And so the first thing we need to kind of figure out is how to switch to and from logarithmic form. So it's kind of always switching one way to the other. And so the two forms are exponential and logarithmic, which I'm just going to call log form. Okay, so let's build the exponential one first. And so the exponential one, I'm going to kind of color code this. And so I'm going to call this b to the power of x. And then there's always going to be an equal sign. And I'm going to let that equal y. So there's kind of three aspects here. We have, first of all, we have the base. The base is the thing holding up the exponent. We have the actual exponent, and that's up here. And then we have kind of what it's equal to. I'm going to call this the answer. Now, when we switch this into logarithmic form, first of all, we're just going to have to write the word log. So whenever you're in log form, there's just going to be written the word log. And then every log has what's called a base. The base is written in subscript, and the good news is it's the same as the base over here. So it's written kind of subscript, which is like small letters down below, but it's the same number as whatever was in the base over on the exponential form. So that's the base right there. And then inside of the log, you're going to put whatever was the answer over there, and that's now called the argument. And then there's still going to be that equal sign now. And then over here, all by itself now is going to be x. And so whatever was in the exponent now is no longer in the exponent. It's kind of just all over there by itself. All right, and so that's kind of switching from one form to the other. And like it says up here, you need to know both. And so in the first set here, we're going to rewrite these in exponential form. So the first thing we're going to do here is that it's given to us in this form, and we're going to move it over into that form. So let's go ahead and do this. So number one here, we have log base 15 of y equals x. And so I see that this is our base, is 15. And so when I write it now in the exponential form, I'm going to write a normal size 15. So in the log form, it's like a small number that's down below. But in the exponential form, it's kind of a regular number, as you can see there. Now, its exponent is going to be the number over here. This is going to become our exponent. And so the x is going to go up there. And then y is going to come over here all by itself. So the base kind of turns into the base. What I always say on this one is the base, and then it gets a new partner. So you can see 15 was with y here, but now 15 is with x. It's still the base, but now it gets a new partner. All right, next up here, we have number 3. And so for this one, we have our base here is 12. And so I'm going to say 12 to the power of, and then it's going to get a new partner, and the new partner is -2. And that means 1 over 144 is kind of all by itself over there. With this one, since we have numbers here, we can actually check this out. 12 to the -2 actually does equal 144. Remember, a negative exponent moves it down to the bottom. And then so it's 12 squared then on the bottom, and then we square it, and then it's 144 on the bottom. So this is certainly true right here. This is our answer since we're just changing the form, but that also means that that original log equation was true. Okay, next up here, number 5. Now, number 5 and 6 here has a very important thing. Let me move down and give myself some space here. So number 5 and 6, you can actually see that, excuse me, these have no base, And whenever it has no base, it really does have a base. It's just an invisible base. And that invisible base is always equal to 10. 10 is just kind of a really important number when it comes to these logs and exponents. And so when you don't see a base, it's always assumed that it's a base 10. And so if you want to write the base in there as a base 10, that's fine. And so now when I switch it, I know my base is 10. So I'm going to say 10, and it gets a new partner to the power of 1 equals 10. All right. Now we're going to kind of go the other way with this. And so on these ones, we're going to write these in log form. And so now it's given to us as an exponential, and we're going to switch it into a log. And so for this one, I'm first going to write the word log, and then I have to identify my base here. And my base is what's holding up the exponent, so that's going to be base x in this case. And then inside of the log, it's going to get its new partner still. So the new partner is going to be 183. And then whatever was in the exponent is going to be all by itself now. So that's now a regular y over there. All right, next up here, same idea. So number 9, we're going to build a log. And then the base of the log is going to be the base here. And that's a base of 13. And then inside the log is the new partner. So that's 169. And then that's going to equal 2. All right, and then lastly here, we have here a base 10. And so we're going to write a log here, base 10. But remember that if we write no base, then that implies that it's an invisible base of 10. So I'm not going to write a base on this one. I'm going to just leave it blank, and that's assumed that it's a 10. And then I'm going to put in the new partner as a regular number here. And then that's going to equal what was in the exponent, which is m. So whenever you have a log of base 10, it's actually not wrong to write the base 10. But usually they just leave it off. Kind of think of it like if you have 1x, usually that's just written as x. And so same idea here. All right, last set here, we're going to evaluate these expressions. So you can see that these are logs here, but they're not equal to anything. But we're actually trying to find out what they're equal to. So on all of these, I would always make them equal to x. And so then what I would do is I would rewrite it in the exponential form. So I would do this this pink switch from log to exponential that we did before. And so if I did that, I see that this one has a base of 5. And so I'm going to say that this is 5 to the power of, and then it gets the new partner of x equals 125. And then after that, I have to figure out, well, what power turns 5 into 125? And so that is going to be the power of 3. 5 to the third power gives us 125. Next up here, number 15. So for this one, once again, I'm going to set this equal to x. I realize that this is a base of 4. And so I'm going to say 4 is my base here. My new partner is x. And then so 4 to the x power equals 1. And with that, I know that the 0 power turns everything into 1. And so I'm going to say that that's the 0 power. All right, and lastly here, number 17. So for this one, I'm going to set this equal to x. And then I see my base is going to be 7 here. And so we're going to say 7 to the power of x equals 1 over 49. Now I need to remember here that the negative, and I'm going to write my answer over here. Well, actually, I'm going to write a little note here. Since it's on the bottom, this is going to be a negative exponent that sends it to the bottom. And so I know x is negative since it's on the denominator. And then so what turns 7 into 49? Well, that's a squared. So it's going to be negative 2. So anytime you're moving it to the bottom, it's just going to be the negative version of that exponent.